Number 61, we're given the log equation, the log base 16 of x is equal to 3/4. So to solve this, we're going to start by rewriting it from a log equation into an exponential equation. So what that would look like is 16 to the 3/4 is equal to x, which means in order to solve for x, it's just a matter of evaluating 16 to the 3/4. So that would be equivalent to the fourth root of 16 to the third, which the fourth root of 16, what number times itself 4 times gives you 16? That would be 2. And then 2 to the third is equal to 8. Number 64, we're given the log base 5 of 5 to the log base 3 of x is equal to 2. So here again, we're going to start by going from log equation to exponential equation. So that will look like 5 squared is equal to all of this stuff after the logarithm. So 5 to the log base 3 of x. And now this puts us back into the situation that we were in section 7.1, which told us that if we're solving an exponential equation where we have the same base on both sides, we can just drop those bases and set the exponents equal to one another. So because both sides have this base 5 in common, we can just say 2 is equal to the log base 3 of x. But now the situation we find ourselves in here is, again, we're trying to solve a log equation, which means we want to rewrite it from a log equation into an exponential equation. So what that would look like here is 3 squared is equal to x. And then finally we just need to find 3 squared, which is 9. And that is our solution. Number 66, we have the log base 3 of 9 to the 2x is equal to negative 2. So what this would look like as an exponential equation is 3 to the negative 2 is equal to 9 to the 2x. So what we're going to want to do with this one, since we see different bases on both sides, is we want to rewrite one of them so that we can get the same base on both sides. And then we'll be back in the situation like we were in number 64. So probably the easiest thing to do in this case is we see a 3 and we see a 9, and we know we can turn a 9 into a 3 by squaring it. So the right side is the same as 3 squared to the 2x. And then we can multiply our exponents to get 3 to the 4x. And now because we see that base 3 on both sides, we can drop the 3's and just set the exponents equal. And then to solve for x, it's just a matter of dividing both sides by 4, and then negative 2 over 4 reduces to a negative 1/2. Number 68, we're looking at the log base 7 of 3x equals negative 1. So what would this look like as an exponential equation? 7 to the negative 1 is equal to 3x, which 7 to the negative 1 is the same as 1/7 is equal to 3x. And then to get the x by itself, I would have to divide both sides by 3's. But because I'm working with fractions here, instead of thinking of it as dividing by 3, I'm going to think of it as multiplying by 1/3. I'm going to multiply both sides by 1/3, and then 1/3 times 1/7 would give me 1 over 21 is what x is equal to.